Thank you. Can you guys hear me? Huh? Because it's weird, because if I was like a rapper, I'd be like, turn me up in the monitor, because I can't hear myself. But we don't have a monitor, so it doesn't
You can turn yourself up in the monitor, but it's a display.
It's a monitor. So before I start, you have to forgive me. I'm actually controlling Keynote with my Android phone because that's how I roll. So today I'm going to be talking about Ruby simulators. I actually have like a whole day exposition on writing simulators in Ruby, but as I found out yesterday, I only have 30 minutes for this talk. So this is just going to be part one. So the introduction. Oh wow, we got lag. I'm Bryan Liles. I actually work at Thunderbolt Labs, the aforementioned Thunder company, under the bus company, and we do awesome things. I do it from Baltimore, other guys do it from Portland, other guys do it from San Francisco, but that's not what we're here to talk about today. Today we're here to talk about simulations. And really, the kind of simulation I'm talking about is simulating a group of people doing stuff and actually figuring out what's going to happen. So we have a group of people, they do stuff over time, and what they do is they get together. Like this white chick gets with this black dude. This black dude gets with this other white chick. This white chick right here gets with this guy with the V-shaped forehead, kind of cool guy, artistic. And this guy goes both ways. He gets with everybody. So we're going to talk about modeling this. And why are we going to talk about modeling this? Well, let me show you why. Sound guy. God.
But I didn't want him
I'm
to
just kidding.
think I didn't trust him. I didn't know I could catch it on the playground. We were in love, so I didn't think about it. All I did is trade Lunchables.
Every year, 2 million kids are infected with cooties.
Why didn't you tell me, baby? I thought cooties was something that happened to other kids. Cooties! I just wanted to play tag. I never thought I'd be it.
And the numbers are growing.
I blame myself. Shh. I made a big mistake.
And even though a vaccine is available,
Circle, circle, dot, dot. Now you have the cootie shot.
most children never get inoculated.
You may have cooties and not even know it. I wish someone had told me.
Speak to your kids about cooties before cooties speaks to them first.
What do I do now?
So I'm here today to talk about the epidemic of cooties. I mean, I'm sure some of you in this audience have cooties right now. So what I'm trying to do is we're going to build a simulation to help world policymakers and public health people understand the effects of cooties on a population. So what would I do? Well, of course, what I would do is build CootieSim 2012. And because this is an arbitrary thing, and let me pick an arbitrary language to build it in. So I'm going to build my cootie simulator in Ruby. And first of all, I know what you guys are thinking. If you're going to build anything performant, why would you build it in Ruby? Well, why not? Ruby is extremely expressive. If you use things like JRuby, you have full power of the JVM. If you use MRI, it's quick in some things, not in others. So let's talk more about the simulation. So there's two types of real simulations. There's stochastic and deterministic. The difference is deterministic simulations actually run the same way, given the same set of inputs every single time. And stochastic actually uses, we won't step on the carpet. It actually uses random inputs. So we're actually going to use random inputs. And I just wanted to get that out of the way in case somebody was a smart ass and wanted to ask me what kind of simulation we're going to build. So to build our simulation, what we're going to do is we're going to define inputs, we're going to compute, and we're going to analyze the outputs. Very simple. And anyone in this, and what I'm trying to prove is that anyone in this crowd who actually can code in Ruby, even a little bit, can write this kind of stuff very simply. So to throw some code at you, because we are at a RubyConf, this is what my simulation does. It took me about 40 seconds to write this and just throw up a slide of this is what our simulation does. I'm not going to explain this, but basically, I'm going to explain it. Basically, you have people, and then you run some kind of loop with simulations, and you report on that. Now, let's go into this. So we're going to define our inputs. And actually what I'm doing here is I'm actually going to build up an app that I'll actually show you run, and this will be most of the code. So we're going to have a simulator. So because we're using Ruby, we have to use classes. You'll notice my last slide didn't have any classes on there, so I have to have a class. So you create a class named simulator. We're defining inputs. And the next thing you want to do is compute. And really for our simulator, all we need to do is we need to create pairs, and then we need to transmit our cooties, and then we need to progress the cooties, because you know what? Cooties actually, there's a cooties disease, there's a cooties infection, and there's a cooties disease. You don't want the cooties disease. And then we're going to analyze the output. Simple things here. We're just going to actually just print it out to the screen at first. So let's go into this even more. So with our cootie simulator, our simulator works day by day. So every day, we're going to create new pairs of people. Everybody goes out to the playground, and they go find somebody to pair with. And then we're going to see what happens. So how do we create pairs? Well, this is very simple. Creating pairs is we just actually have a method for people not in pairs for the particular iteration, and then we shuffle each slice, and we map. One thing I want to point about this, I actually asked everybody at Thunderbolt to run this, and even they didn't realize that this code will not run in Ruby 1.8. It can't run in Ruby 1.8 because of the dots. Ruby 1.9 got smarter and said that, hey, we want to do it Java style and be able to have like a builder type pattern and be able to put like dot shuffle, dot each slice. In Ruby 1.8, you can't do it. You actually have to have the dot on the other end. I'm glad they actually made that change. But really simple code here. And then we want to transmit cooties. And how will we transmit cooties? Well, very simple. All we need to do is a person has an infect and acquire. And what they do is if people are in pairs and you infect someone and then they acquire the disease. So like I'm saying, what I'm showing here is this very little code to actually move this forward. And then we want to track infection progress. And once again, you know this is Ruby because all the indentation. So very simply, once again, and I promise I will not throw too much more code at you guys. I just like to see it on the screen because I wrote it. So like I said, this is not deterministic. This is stochastic. And you notice that I have if rand. That right there means that every single time it runs, it actually will have different types of outputs. So one thing to say, this is not going to be fast, and I'll show you why this is not going to be fast. When I run this for, let's say, 365 iterations, so let's say 1 year, with 100 people, it takes 28 seconds on my Mac. My Mac is pretty fast. I actually have one of these newfangled Macs, and it actually ranges from like 28 to 50 seconds. But that's only 365, that's only 1 year with 100 people. That's not modeling anything. So let's look at why Ruby is not fast. So this right here is actually output from RubyProf. Anyone here use RubyProf? Why is everybody's hand not up? You should use RubyProf. I know most of us do web apps, and they don't have to be fast because you cache, and that's how you make web apps fast. But in the real world, you got to use RubyProf. And what RubyProf says, what we already know, going through arrays is slow, especially when you have very large arrays. So want to talk about, anyone here know big O notation? Can people tell me the difference between like log square and n squared? What's the difference between like n squared and 1? Anyone know? So really, Ruby arrays, worst case, are if you want to actually iterate through an array, worst case is order of n, because you have to look at every single host, everything in there. One thing I don't like about Ruby that I really wish Ruby had was better data structures. I mean, you can create them, but out the box, you get a hash, you get a scalar, you get an array, and you don't even get a cool array. You don't even get like a linked list array. You get just an array. So what other things can we do to speed this up? Well, another thing you can do to speed this up is you can run more than one thing at a time. So let's imagine that on enumerable, we actually had a parallel each. And what it did is, as it went through, it would actually create a thread, and it would yield, and then it would do a cleanup for the thread. And then you could actually run, whenever you iterated through an array with each, you could actually do more than one thing at a time. And you know what? Someone thought this was a good idea. Jim install Peach. You guys can't see what this says because if anyone saw this slide, it actually says YMMV. And the reason it does say that is because you don't want to do this. Don't gem install Peach. It'll actually make it slower because really what it does, it tries to create a thread pool and it actually runs each. It actually breaks up your each and tries to run it in a thread pool. But the problem with Ruby is creating a thread is not very fast. So by the time you create your thread, if you have something that runs in 1 millisecond, you've already lost out. So don't do that. So anyone know what this is? Yes, this is PerfTools. This is output from PerfTools. So the difference between RubyProf and PerfTools is PerfTools is a sampler, and RubyProf is a proper profiler. And what PerfTools will do will actually add set iterations in your code. It'll actually see what's running. And right now, we can see that we spend a crap ton of time in the garbage collector, and we spend a crap ton of time in going through, once again, iterating through an enumerable. So what can we do about this? We're not going to talk about that yet. So I was trying to illustrate the point here that we have 100 people times 360 or 3,650 iterations. I mean, that's 365,000 actions. And that's just for a very small simulation. So I have to have one slide in my talk that has like cool effects, and this one might be it. There it goes. So I found that I could do this Star Trek thing, or this Star Wars thing, and I was real excited. I spent like 30 minutes on this. So here's where we want to be. We want to actually find a population of 1 million people. So think about it. That's 3 billion actions. I'm a computer guy, not a math guy. So this talk is about simulations, but really what I'm getting down to is how do we make Ruby faster? I'll tell you one secret. You can't make Ruby faster. It's impossible because you just can't. But there's 2 things we can do. We can run less code, or we can do more than one thing at once. So let's look at this. Using MRI 1.9, whenever we execute code, we execute and pretend that this thing right here is your CPU because this is how your CPU looks. Mine has 4 cores plus 4 hyper-threaded cores. We're not going to talk about that. So I can run 1 task, 2 tasks, 3 tasks. If I do thread.new, what happens is I still all on 1 core, but I can do more than one thing on 1 core. So what does that mean? At best, I'm only using 25% of my CPU with MRI for 1 process. Anybody want to refute that? Okay, just making sure. So with JRuby, same thing, 1, 2, 3 serial actions, or 3 synchronous actions. Whenever I do thread.new in there, I can actually go across my cores. So this makes you think, well, why in the hell would I ever use MRI? Well, I can give you like 100,000 reasons why you would. It starts up slow, it takes a while to spin up, and it uses more memory, and it's not compatible, and a couple other things. So, but you have to understand that whenever you want to do these kind of simulations, what are you doing?
Well, I was going to say with MRI, if you're only using 1 core, you can actually turbo boost and get that core up to maybe as much as 110% speed. So you can actually use about 26 or 27% of your processor's capacity.
No, and you know what? You are absolutely correct. You know, and I will not refute that because if you go into Activity Monitor, you can see that it does go above 100%. But only a little bit. And the problem is, even with Turbo Boost, so let's say my Mac is a 2.7 gigahertz i7, it turbo boosts to 3.7. It's not like it's turbo boosting to like 11. So, here's my first thing. If you want to do something performant in Ruby and you have Ruby code that you just written on MRI and you wonder why it's so slow, just take it out and run it in JRuby. I made no tweaks to my app, and I ran it in JRuby, and it actually ran in less than half the time. That's a weird case, but it did run in less than half the time. How much time do I have? Lots. So here's a weird section. How do you do more than one thing at once at MRI? Well, you can use queues. Real popular thing with queues right now, Redis backed. How many people here use Rescue? People here love Rescue? How many people use Sidekick? How many people love Sidekick? Wow, one guy likes Sidekick. Sidekick is awesome, but let me tell you why I can't use it in my simulation. Sidekick is like the fire hose of Redis back queues. You can, sure, I think even on the page, the guy Mike says that you can do 100,000 actions per second. But what if I don't want to do 100,000 actions per second? What if I want to create one batch that has, let's say, 95,000 things in there, and create a second batch that creates 95,000 things? With Sidekick, I can never be guaranteed that the queue is empty and I can move on to my next iteration. So really, it's like up and down, and it actually doesn't work very well. I'm not saying that Sidekick doesn't work very well. It doesn't work very well for me. So how many people here have used Girl Friday? Girl Friday is awesome, and actually it's even extra awesome under JRuby when you can use real threads. I expect everybody to check it out. Actually, the same guy that wrote Sidekick wrote Girl Friday. This guy's really on some queues. Other types of queuing are memory backed. RabbitMQ. Did I really write memory backed? Oh, I'm sorry here. It's not so that. It should be like AMQ backed. So people doing high concurrency and a high amount of traffic using things like AMP queues or AMQ. Yes, you know what I'm saying. So, and then there's also DB backed. Does anyone? Oh wow, This is Android with Apple. It's not working well. So socket-based concurrency. People are using ZeroMQ and dcell. Anyone here use dcell? I'm using dcell, so I guess I can raise my hand. So moving on to something more exciting, statistics. Anyone here good at statistics? Statistics? I can't even say the word. So whenever you're doing things of this nature with simulations, you're going to have a lot of stats coming out. So important things to know, mean, median, variance, standard deviation. Everybody knows the mean, add it up, divided by the number of things that you added up, you get the mean. Median's the number in the middle. You know what the variance is? Variance is how much the numbers vary, but no one really uses variance. People actually use standard deviation, which is the square root. Is it the square root of the standard of the variance? Yes. That's what it is. See, I'm learning. Actually, I know Randall Thomas is not here. He's going to do a talk on. Oh, you're brown. I can't see you. Smile. So standard deviation, square root variance. So another cool thing, and I was just talking to somebody a little while ago. I don't do much open source, so when I do open source, I like to talk about it. So Jim installed Vose, and there is no disclaimer underneath this. What Vose is a Ruby implementation of the Vose alias method. And what the Vose alias method is a way to sample probabilities in real time. And I'll show you one cool thing you can do with it. So let's say you had a die, and the die had it's a six-sided die. We're not playing D&D here, just a six-sided die, and you're playing craps or something, and you roll it. What's the probability that a 2 comes up? This is what I'm sampling here. So I have an array with 6 items, 1, 2, 3, 4, 5, 6 in there. And what I'm doing is I'm actually sampling this a whole bunch of times to make sure that 1 through 6 come up evenly. And you can easily do this with Rand, same code with Rand. I did use an inject. And actually, Tamer Saleh, I showed him this code, and he's like, what are you trying to do? Brain fuck me? He does not like inject. I like inject for this kind of stuff. Ryan Davis? Yes. How you doing? No, actually, I usually don't use inject, but I wanted to, like I was explaining to him, I wanted this to show up on 1, so I did use inject. And really all I'm trying to do is show that it's the same amount of code. And actually right here, Rand is actually faster than my Vose alias method. But I'll show you something that Rand can't do. So what if you had a crooked die like I would like to roll with, and your 6 actually comes up. Your 6 actually comes up more often than or actually your 1 comes up more often than any other number. So this is what the Vose alias method is for. Actually, I can actually say that my 1 comes up more often. And you're like, well, why would I do this? So if you're sampling mortality rates in a group of people, and you say that 10% of the people die at 70 and 10% die at 71, or no, even better yet, you have a 0.01 chance to die at 70, a 0.01 chance to die at 71, and then you have like a 0.03 chance to die at 72, You pop all those in an array, you pass that to the Voles-Elias method, and you just choose next. And it'll tell you when you die. So, moving on. So, graphing. We like graphing. I know most of you guys are probably familiar with more like high charts, JQ-plot, things like that. This is not a web app, so there's none of that. So if you want to do trend graphing, and actually, a very important thing is I run this simulation a lot of times. Sometimes I run it, maybe a couple hundred times a day. And what I'm trying to do is actually a slow iteration, a slow day for me would be 1 millisecond. So this is the kind of level that I'm working on. Slow iteration is 1 millisecond. Actually, in Java, it's way less than 1 millisecond. It's like a quarter of a millisecond to run one day. But so what I want to do is I graph all this stuff. So this is a graph of how long it took over time, and you'll notice that it goes up linearly and then it gets up here. My guess, all this stuff up here is actually I was getting into Ruby garbage collection, and that's what happened. Garbage collection started happening a lot more often, so it actually got a little bit off kilter. This right here is the same code, and it's actually JRuby. So what you can see right here, anyone know what this right here is? Yeah, it's hotspot. It's hotspot. So it was JRuby actually without hotspot would be slow as crap. So it goes up, and then hotspot kicks in. And you notice that the slope of the line is actually way less. And this is the clue that for things that you need to be performant in, I wouldn't say your web apps, those are weird. But if you're actually writing performant Ruby, I would know it's an oxymoron, look at JRuby. Notice I didn't do Art Rubinius or maglev. I love those projects as ideals, because I'm idealistic, but I wouldn't really use them for this. So how did I do that? So I tried doing it in Ruby and then realized that there's much better things out there. This is R. And I know a lot of people in here want to be experts at R because you can write cool code that no one can understand here. Like on this third line where it has the mygg with the arrow pointing to it, that's actually, I know it's like an equal sign or it's like a pinned onto it sign, but I really don't understand how it works. This is actually just all scarfed off the internet, curculted for this talk. But what it did is it does create these graphs. I do know what the next to last line does. It sets the output file name. So that's R. So the next thing you want to do is visualization. And a cool thing that you can do is, and this is actually something very interesting to me. So I created all these, graphs, and I wanted to see from patient 0, like person 1 always has cooties. Who is person 1 giving it to? So if you look all the way at person 1, and then down here at person 8, this is actually, I just drew this little graph here, and this is just GraphViz. And it's actually very easy code. You guys should definitely look at GraphViz if you're doing this kind of visualization. It's really simple. Actually generate this from Ruby. More cool effects from Keynote. So, back on to building a simulator. How much time do I have? Oh my gosh. A simulator goes around and around. It's a loop. Like I said before, there's people. Every single day, we have a selection of people who are available to run. And then when those people are available to run, what we do is we pair those people up. So we know that this old guy likes little girls. And actually, that's just how it happened. I didn't really pick it like that. And then I guess this Asian dude with long hair is not a girl. And this other girl, they like each other, and this black guy is just hanging out. So when they pair, then they share cooties. And this is my visualization of cooties being shared. So how do you make it fast? One thing to do is be kind to MRI's GC. Does anyone here know why Rails is slow? Besides Ryan, I'm sure he knows why Rails is slow. One reason Rails is slow, if you ever dumped memory, like object space, Rails creates a shit ton of strings. So you know one thing to do? Just don't create any strings. That'll be much easier. Also, run with more than one process. And look outside of MRI. And when you're looking outside of MRI, remember I said before that JRuby is not compatible? And I brought this up. I refused to go into the JRuby bug tracker because they say that it's going to be Ruby 1.9.3 compatible. In Ruby, you can actually pass a range to rand. Not a lot of people do this, but I wanted to do this. I want to be able to say between day, and I want to have a relationship that starts on day 1 or ends 1 day from now or 7 days from now. The best way to do this would be rand with a range. You can't do this in JRuby. So you have to be very careful about this. So you have to make sure that you're testing on both platforms. And notice it runs on Ruby 193 just fine. You might also want to think about other languages. I literally spent 2 weeks trying to write this in Clojure. And you know something? That's exactly how I feel about it now. And not saying that Clojure is a bad language, I'm just saying that, you know what? We're very good at imperative languages, and I have yet to find a definitive problem that I cannot solve faster, and this is just me, in my imperative languages than I can solve in a functional language. I mean, I'm sure there are use cases. Most of us won't run into them. So, Ruby is a compromise. There's a compromise on speed. There's a compromise on just not knowing what's going on. You can hook up Visual VM to JRuby, but you will not get the same view that you would get if you hooked up to a regular old Java project. So I was going to bring up some code, and I have 2 minutes. So I have a couple minutes, right? Yeah. Yes. There's no timer here, so I'm just winging it.
No, we got time. We have 5 minutes.
All right, 5 minutes. So I'm going to show you how easy it is to write these kind of simulators in Ruby. And don't make fun of my editor. I use Sublime Text. And what I'm going to try to do here is, can you guys see that? Should I make it bigger? All right, I'll make it bigger anyways. So what I have here is my Simulation Charlie. And the reason I call it Simulation Charlie is because I know we have a version control, but whenever you're writing code for a talk, using version control is actually very hard, for me at least. So there is no version control on this. I just did it old school, like Cold Fusion guys would, and actually just copied the file to a new name for every iteration. So what I have here is I'm going to drag over a terminal as well. There we go. I have a terminal, and there's my IP address. And so I have let's see, tab. Oh, that's even worse. Yeah, sad trombone me, somebody. There we go. There we go. So we'll just type in the top left corner of the screen. So I have 2 versions of this thing. And so if I run the simulator over, let's say we'll run it over 10 years with 100 people from Ruby, and it runs fairly fast. But whenever I go up to 100 years, you can see that, hey, you're thinking it's scrolling really quickly. You can actually control the number by changing the modulus and the print. So you think it's pretty fast. But look, this is the same code. And actually, this is like a little preview. I'm talking at Windy City Rails about cool shell tricks. Look what I'm getting ready to do. 2 terminals sharing history. That's pretty awesome. You should know how to do this. So the same file actually running under JRuby, it actually runs way faster. So that's 5 seconds versus 6 seconds. That's way faster, and whenever you're doing simulations. I mean, it's like a few thousand milliseconds. So think how many nanoseconds or microseconds that is. That's actually pretty fast. But here's the worst thing, and I hate this because I am a Rubyist. We actually have a Java version of the simulation, and we'll run it with the same constraints. And this is why you should always look outside of your comfort zone. So I can make it faster in Ruby, but it's still going to be slower than Java or C++. So that's the lesson to be learned from this little talk. So thank you guys for not heckling me too much. It's been fun.